Hi everybody, so today we're going to talk about Pythagorean identities and factoring. So let's talk to you today first about what the Pythagorean identity is. So you're going to think about this as a right triangle sort of inside of a circle with a radius of 1. So we know that we have an x distance, which we typically know as cosine. Cosine is our horizontal side. And we also have a y distance, and that's typically our sine. And we also know that our hypotenuse is going to be 1. The Pythagorean theorem says that a squared plus b squared equals c squared. So our a is our x, or our horizontal side. So that's x squared, which you know is cosine squared. Our b squared, or our other leg, which is sine squared, is going to equal our hypotenuse, right, which is c squared, which we know in this case will just be 1. Now, what we're going to do is we're going to say, all right, well, cosine squared plus sine squared is equal to 1. It's just the Pythagorean theorem that's applied to a triangle whose hypotenuse is 1. So we're getting all that information from the Pythagorean theorem. So that's our Pythagorean identity. Sine squared plus cosine squared equals 1. Now with this first Pythagorean identity, you can derive the other two, and we've showed you that proof right below here. So you get the tan squared plus 1 equals secant squared. And then you get 1 plus cotan squared, which is equal to cosecant squared. All right, so here we've got sort of a list of our Pythagorean identities to make it be a little bit easier for you. So now this is a little different because it's important to remember that these identities, they have to be squared. The other identities that we had in our previous video, you could have your function squared or not squared. It would work either way, but with the Pythagorean identities, these have to be squared. Now, you can also think about the Pythagorean identities as almost sort of like a rearranging tool. Now, what you might notice is you might have an identity that looks very similar of these identities that you see here, but you might have to do some rearrangement. So maybe you would see the exact same identity, but maybe you might have to move one function over to the other side. So just know that you can do some rearrangement with these identities as you're working with either simplifying or verifying your trig identity. So let's go ahead and look at factoring this expression and then simplifying when it's possible. So the first thing that we like you to see is that you do have a common factor. Now that common factor between your two terms is sine of theta. Now if you were to take that sine theta out, you would get sine squared theta plus cosine squared theta. Well, we know that sine squared plus cosine squared equals 1. So sine of theta times 1 is going to equal just sine of theta. Okay, so in question number 2, what if I were to say, all right, well, let me figure out what I have, right? So what if instead of having sine of theta, like what if I said that that was the same thing as x, right? So if I said this is x to the fourth minus 2x squared plus 1, that might make it easier for me to go ahead and factor. So I know that that would be x squared minus 1 and x squared minus 1. Well, then what I would do is I would say, okay, well, I'm going to look at my x's now, and I know that my x's was really sine, so I could replace that, right? So I can say, really, what I have, what I factored, is instead of x squared, I'm going to have sine squared of theta minus 1, and then again, sine squared of theta minus 1, okay? Well, from one of my identities, I know that sine squared of theta minus 1 is the same thing as negative cosine squared of theta. So I got negative cosine squared of theta. And if I wanted to go ahead and simplify that and multiply it, I would get cosine to the fourth of theta. And it would be positive because negative times negative gets me a positive. Okay, so in number 3, we have two different functions actually. You have cosecant and you also have a cotangent. But what I can say is that I know that cosecant squared is the same thing as 1 plus cotangent squared, right? That's one of my identities. And then I know that I have a minus cotangent of theta. I know that, right? That's the same. Okay. What you could do is say, all right, let me just rewrite this in order. So I have cotangent squared of theta. I have a minus cotangent of theta. And then I have 1 minus 7, which gets me a minus 6. And then you can ask yourself the same question you did in number 2, right? Like, what if I were to make, let's say cotangent, what if I were just to make that as an x? Then I would change my question into x squared minus x minus 6. So I can factor that, right? I would get x minus 3 and x plus 2. So then what I would do is I would take these x's now and then just replace it with the cotangent. I have cotangent of theta minus 3 and cotangent of theta plus 2. Nothing more you can do with that. So we're going to go ahead and have that as my final answer. Okay, in number 4, what we're going to do is go ahead and verify. So remember, verifying is just making one side of your equation look like the other. So what I can see here is I have an identity. This is the same thing as cosecant squared. I'm going to bring down my sign of theta. Okay, well, what I do know is that cosecant squared is the same thing as 1 over sine squared of theta. So what I can do is I can say, oh, I have 1 sine on the top, and then I have 1 on the bottom because I technically have 2 because it's a squared. So I have 1 over sine of theta, which I know is the same thing as cosecant, which is what I wanted. So in question number 5, I'm looking at the left side and the right side of my equation, and I see that I have to actually do something with this cosine squared of theta because I don't have any cosines on the right side. So as an identity, I know that that is the same thing as 1 minus sine squared theta. And if I bring down the rest of my question, what you need to be careful of is when you're subtracting a quantity, it's going to actually flip the sign. So it's -1 and then a plus sine squared of theta. Okay, so what we have is we've got, we forgot a 2 here. What we do have is a sine squared and another sine squared. So you have 2 sine squared of theta, and then you have this -1, which does match to what I wanted on the right-hand side. Now, I hope you found this video helpful. If you want a refresher on the other identities, don't forget to check out the video above. Thanks for watching and have a great day.